Good day, folks. In this video number 9, I'm going to be talking about the rolling joints which you can create in the motion design application in 3D Experience. The problem that I'm going to do actually, there's going to be three videos. This is the first one. They're all going to be in the kinematic domain. So the playlist that you will find this thing in is motion design uh, kinematics problems. Actually, I have a geometry that's shown here. It's taken out of Higler's book, and you are told that the shaft is revolving about the z-axis at 2 radians per second, and we are assuming that the wheel rolls on the ground without any slip. So the geometry that I'm going to model is shown on the left, as you will see in a few minutes. And we are also told, or we are asked to solve this problem, solve in the sense that simulate this problem and get the angular velocity of the wheel uh, as a function of time later on. Actually, this can be done manually in the sense that the spinning, if you take the 2 radians per second and you multiply it by that radius, which is 800 millimeter, you're going to get the velocity of the center of the disk uh, in the horizontal direction. And if you take that velocity, which is going to be uh, obviously 800 times 2 radians per second, and divide it by the radius of the disk, the wheel, you're going to get actually the spinning angular velocity of this wheel. So 4 rad per second is the angular velocity of this wheel about its axis. It's called spinning angular velocity. And if you take the square root of 2 squared and the spinning square that you got here and add them up, take the square root, you're going to get the angular velocity of the shaft in magnitude. Because notice that this shaft is spinning about the y-axis and it's also spinning about the z-axis. So the angular velocity of it is actually the combination of the two in that fashion. Okay, now here's the way I'm going to do that. The way that I'm going to do this problem, and there are many ways of doing it, is 2 revolute joints for the connection between shaft and the earth and shaft and the wheel. And there's going to be a curved tangency joint which allows this wheel to roll along that path without any slipping. uh, Notice that I said that the wheel rolls along that path. The only thing is that there is no roll curve joint that you can actually find it in CATIA V5 or in the uh, uh, mechanical system design of the 3D experience. There is a roll curve joint there, but you don't find that roll curve joint in the list of joints that you can do in motion design. But it's buried in here. Both slide curve joint and roll curve joint is hidden down there. So this is not available. Instead, you have to do that manually. You have to create the joint manually. You click on the joint icon and you select it from the list curve tangency joint, and then the arc of this, or the perimeter of the circle of the wheel, the perimeter of the circle on the earth, and make sure you activate the rolling. And if something doesn't look right, try to uh, you know pick the opposite instead of identical. And here is some help in the online documentation, which is not very extensive. Okay, let's go ahead and do that. I'm going to start with an assembly, and right away insert my first 3D part, which is going to be the earth. I'm going to call this thing right-click properties. Notice that I'm not calling it ground. I'll come back to that in a few minutes. Earth and earth. And let me make the color of it yellow. All right, let's go make it. So double click on 3D part. I'm in part design now. On that horizontal plane, I will sketch a square which is 2 meters by 2 meters. So let me go ahead and make this thing 2000 millimeter. My unit, sorry, yeah, my unit millimeter, and this is also 2000. Oops, 2000, another zero. Good. Now for the shaft connection, I'll make it a hole there. So a little circle, I'll make it concentric. Okay, that's good. Exit and add it. Let me see. Did it go up? I want to make it go down. There. Okay. Now on that top face, I will sketch the circle, which will be the path of the wheel. So that circle is going to be radius 800 millimeters. There we are. Exit. And so we have our earth. There is a hole here for the shaft to go in. And then there is this circle of radius 800, which is going to be the track or the path of the wheel. Okay, now let's go and do the shaft now. So right click, insert 3D part. I'm going to call this thing shaft. If these operations are easy for you, you might as well skip it to where after things have been finished. So as far as assembly and parts. So this is going to be shaft. Shaft. All right, now let's color it. I'll make it orange. Okay, so to go to part design, make the shaft. So let me do that on that XY plane. We'll sketch the cross section of the shaft, which is just a circle. So I'm going to sketch here. So what is this? Sketch. And instead of drawing another circle of that size, I'm going to project that. Make my job easier. I'm going to project that circle. Okay, and there we are. You can see that. So exit. Now, because the shaft, I'm going to make it a rib operation. I have the thing that's going to get ribbed or extruded if you want. So it's that circle. It's that circle that I made right there. And then on that vertical plane, I will make the path of that extrusion. So here is how I'm going to do that. Let's put some dimensions. So dimension from here to here is going to be 400 millimeters. And the dimension from there to there is going to be 800. Okay, exit. Okay, there we are. So now we are going to do a rib. Here's a rib. We're going to take that sketch, that first sketch, that circle that I projected. Remember that? And I'm going to, yeah, and I'm going to rib it along the sketch 2, and it looks like that. Maybe it's a little bit fatter than what I thought, what I wanted, but that's okay, no problem. Okay, so now we're going to insert the wheel. So we go all the way to the top, right click, insert 3D part, 3D shape, 3D part, and let me change the name of this thing to the wheel. wheel, and wheel. And we'll change the color of it to green. Okay, let's go do that. We go to part design, double click on this. Okay, on that side face, I will sketch. Once again, I project that, easier. So, okay, it's projected, you can see this. And then let me look at the view from the front. Yeah. And then I draw the circle, which is going to be the actual wheel. And the radius of it is going to be 400 millimeter because I want it to touch that curve, a circle, and it does. Now, because this is going to be rolling eventually, why don't I make a little marker here, a little circle, so exit, exit, and now we're going to pad it. Okay, so, yep, good, and then we say okay. So there is our wheel, which is tangent to that curve. All right, so let's go all the way to the top. And all right, why don't we create our revolute joints here, and we'll worry about the rolling process later on. So let me go to engineering connection, fix, and I'm going to select the earth, and that's fixed now. So let's do our first revolute joint. So a revolute, and there are different templates that we can use. I'll use this one, axis and axis, plane and plane. So let's do that. So it's the axis of this shaft and the axis of that hole, and the plane of the top plane of the earth and the bottom plane of the shaft. And I don't need these last three markers, so just delete them. And then say okay. So this is our first revolute. Let's do another one. Again, same template. This axis and that axis, this plane and that plane. And I know I don't need these three markers here. I'm just going to delete them. Okay, so the revolute joint has been created. Now, when it comes to roll curve joint, I told you that is not available in motion design. However, it is available here. If you go to, I'm not going to use it, but I want to show you. If you go to the engineering connections, pull down menu, the pull down menu will give you the roll curve joint and slide curve joint. But that is in assembly design. It is not available in the motion design. So I'm not going to do that because the whole purpose of this playlist is to talk about motion design. All right, good, good. So we're done here. So now we're going to go to motion design application, motion design. Okay. All right. So this is the new mechanism it's going to create. If you want to give it any meaningful name, just go ahead, but that's okay. I'll leave it the way it is. And I say, okay. Notice that when you look at the bodies here, there is something that's automatically created in motion design for you. It's called ground. This is why I do not want to call this thing ground because I don't want you to get confused. This is made by the software. This is the one that I made. Okay, good. Now what kind of joints do we have? Let's see now. We have revolute. Revolute obviously came from assembly design constraints that I put in there, and then the fixed one. Now, for the roll curve joint, which is not available in that sense, I have to create it myself. So I go to mechanism tab. There is this joint here, joint, and use the pull down menu. you will see at the very bottom called curve tangency. That is the joint which will take care of slide curve or roll curve. In my case, I'm on rolling, and the two curves that roll on top of each other, curve 1 and curve 2. Curve 1, I select the perimeter of that wheel, and for curve 2, I select the big circle on the earth, right there. And if it doesn't look good, and sure this doesn't look good, change this thing from identical to opposite. Now it looks good. Okay, and that's pretty much it. And it really wouldn't make any difference whether he used curve 1 or curve 2, but I'll just leave it the way it is. You say, okay. All right, good. Here is my roll curve, uh, equivalent of roll curve joint. It's called curve tangency. Okay. Now, the other thing is that as soon as I went into motion design, it created a dynamic step for me. Left double click on it. I don't want to do a dynamic step. I want to do a kinematic one. So I just change this thing over 5-second interval. That's fine, no problem. And I want, don't forget to do this because otherwise you won't have access to velocities and acceleration of that. So under advanced setting, use the pull down menu, select the position, velocities, and acceleration. And then we say okay. Now we have to give it the velocity or the speed of the shaft. So to do that, you have to create a driver. There's a driver, see this driver? You click on it. It says, where is the joint? Well, it's the first revolute one that I'm specifying the velocity for it, or the angular velocity for it right there, revolute. And click on this function right there. See that? It says function. Click on this. It's okay. It is constant. It is constant angular velocity, but make sure that you select the proper dependent variable. So that's going to be angular velocity. Notice that the unit is correct, rad per second, and this is 2 rad per second. And if you want to see the plot, show the plot, which is just constant value over a 5-second interval, 2 rad per second. Good. So we close it, and we close it. Now, okay, so we go to simulation. Here's the simulation. You run it. Now, before doing that, if you want to have a preview of it, you can click on this preview animation. Give it a second. It shows you a preview. It doesn't run it, but it shows you a preview. If there are any obvious thing that needs to be fixed, you go ahead and fix it. Okay. Incidentally, if the direction of rotation of this shaft is not what you wanted, you can go and put a minus sign in front of that 2 that I typed in. Okay, so exit that. That's good. Now we're going to go to simulation and run it. Wait until this thing says 100% or succeeded. That's good. You can do animation. You go select your, from the results, you select the kinematic step and go to results. Here is the animation, play animation. Okay. And let's say we do it continuously. Good. So things look good. Now we're going to plot the angular velocity. So we go to plot 2D and we select the wheel, and let's see, angular velocity. Now, this will give you the X, Y, Z components. For example, if I do the Z component, I'm going to get 2. See, that's almost 2. See, this is all within round off. It's 2. Okay, good. But if you want the angular velocity of the whole thing, So what I'm going to do is the following. Let me uh, let me go and change this thing to for example Revolut 3, right? Revolut 3 and velocity. Let's see how we don't want that. You see that? 4 point. This is this is the angular velocity of Revolut 2, which is 4. You can see that it goes between, see, it goes between 4 and 3.99999. Okay, that's for the Revolut 2. Now, if you Revolut 2, which is Revolut 3 actually, which is this the spin. This is the spinning angular velocity. Now, mechanism. Uh, see kinematic measurement. Select the wheel and then say OK. Now go to results. I guess we have to run it before. We have to simulate and run it. Wait until it finishes. Close that. And then we go to results. Results 2D plot. Select the kinematic measurements. And for velocity, magnitude, let's do the angular velocity magnitude. And then add to the plot. And there is your 4.472. Okay, 4.472. So I created a probe here, and then I said, okay, show me the angular velocity of that probe, and you can see that you get 4.472, which is this. If you look at the Revolut joint, you're going to get your 4. All right, folks, so that takes care of this. There will be 2 more videos on this kind of a joint that I'm going to create.